right, today we're in section 7.2, experimental and theoretical probability. All right, these are our two main types of probabilities. There is a difference between them, although calculating them is virtually the same thing. Okay, how we go about calculating them, but they definitely mean two very, very different things. All right, so what is experimental probability? Well, experimental probability is the actual carrying out of some type of a trial. Okay, so instead of saying, well, this is what should happen, it's actually this is what happened. All right, I rolled a number cube 50 times, and here are my results. I spun a spinner 20 times, and here are my results. So experimental probability is actually carrying out some type of experiment. So let me ask you this. This could potentially help you on your homework. What if I want to try something, or it's calling for 5,000 tries? Do you think experimental probability would be very practical?
Yes.
5,000?
No.
No. 5,000 tries on something would not be very practical to use with experimental probability. And that's why we have another kind of probability called theoretical probability. What should happen, but I'm not actually carrying out the experiment. Does that make sense between the two? All right. So my formula, the probability of an event happening, we actually started to write our probabilities this way yesterday, equals the number of times the event occurs. I've seen it written as successes. Whatever you're trying to measure, a targeted outcome, how many times does it actually happen? That goes in your numerator, divided by the total number of trials. Okay? Divided by the total number of trials. All right, so make sure you have that written down. Okay, so let's see how this looks in an example. All right, so the table right here, just a nice little table below, shows the results of spinning a penny 25 times. What is the experimental probability of spinning heads? All right, so if I were to say in theory, it would be a 50-50 chance, right? You either land on heads or you either land on tails. It's one or the other. But with experimental probability, you actually spin it and you record your results. So what is the probability of, what would I write in parentheses? What do you think? Probability of what? Heads. Probability of heads. That's my targeted outcome. And how many times did I land on heads? 6 out of how many tries? 25. And before we jump just right straight to our calculator to calculate the percentage, is there a way that we can do this without using our calculator? Yes. What could I multiply it by? 4. As long as I can get my denominator to 100, multiply top and bottom by 4, whatever my numerator is, that actually is my percentage. That's something you could even do in your head, isn't it? Okay? Which would be okay. All right, you don't necessarily have to show your work. However, I would strongly encourage you to use that mental math. Guys, first of all, it's faster. You can still successfully get to your answer. All right, so it really is, guys, how many times are you getting your desired result out of the total number of tries? All right, so let's look at another example. All right, in this next one, it says it shows the results of rolling a number cube. How many times? 50 times. That's important. That's how many times you rolled it. You actually did that. And the results are shown in the table. So what is the probability of rolling a 3? And what is the probability of rolling an odd number? So I'm just going to measure these results. How many times did I land on a 3?
8 times.
So probability that you what? What goes in parentheses? That you roll a 3 or land on 3, that would be fine too, is 8 over what? 50. All right. Can I calculate this percentage without a calculator?
Yes.
Yes, do it. Go ahead and do it. Don't say it out loud. Kennedy, do you have gum in your mouth? Spit it out.
It wasn't me.
She's definitely a lot more subtle than you are. All right, thank you. Miles, he's my obvious one. It's okay. It's all right. All right, so what can I do, guys? Multiply
2.
top and bottom by 2. Very good. Top and bottom by 2, 16%. All right, what about rolling an odd number? What about rolling an odd number? Okay, so an odd number is 1. And how many times did I roll a 1?
10 times.
So it's 10. Okay, so 10 is my numerator, right? Is 1 my only odd number? No, it's not. So I need to do 10 plus what?
11.
8 plus 11. Very good. 10 plus 8 plus 11 is 29. Over 50. And again, is this one that I could calculate?
Yes.
Yes, go ahead and do it. What'd you get? 58%. Good job. All right, so that's it for example 1, calculating experimental probability. Are you kind of grasping this whole idea of experimental, that you're actually doing the experiment? All right, so with theoretical probability, it is the other side of that. It is what should happen. Maybe the number of tries is like in the thousands. You're not actually going to do that. Does that make sense? It's not practical. So now you're just going to say, well, I mean, if I try it this many times, this is how many times I should get it. Theoretical probability. The probability that an event occurs is favorable outcomes divided by possible outcomes. Favorable divided by possible. Okay? On paper, this is what it should be. Okay? If everything has an equal chance of happening, this is what it should be. All right, if there's no other variables involved. Okay? Okay, so now let's look at theoretical probability. You randomly choose one of the letters shown. So you are not actually choosing it. You're just saying, if I did choose it, this would be my chance of choosing and you have two scenarios. Choosing a vowel or choosing an X. Okay? So we look at these letters, and we're going to now set up our probability. Probability, and in parentheses, it's whatever we're trying to measure, whatever that targeted outcome might be. Probability of a what?
Vowel.
Of a vowel. Probability of a vowel equals how many vowels are in there? 3 divided by 7. And when you divide 3 divided by 7, what's that going to be?
Improper.
All right, it's going to be a long decimal. So this is where you are allowed to use your calculators. Give me the decimal.
0.4285. 4 decimals out.
4285.
Yes. 7-1.
Okay. All right, 0.4285. So I do want to round this to the third decimal place. So what does the 5 change the 8 to?
9.
A 9. So I'm going to say it's going to be about...
43.
You could say 43%. Or you could say 42.9%. Okay. I'm not going to... All right, so you're going to approximate it 42.9% because you are rounding. Either way, if you write 43% or 42.9%. Your directions will not specify on the rounding, so as long as you are very close, like within 0.1%, and I can tell that you did it right, we're fine. All right, so 42.9%. I want you to now calculate for X, and you will have to round it. It's not going to come out evenly. Go ahead and do X. Okay, so it's going to be probability of choosing an X equals 1/7 or 14.3%. All right, who got it right? 14.3. Okay, very good. All right, so that's theoretical. The last thing we're going to do today, we'll save the last two examples for tomorrow, is comparing probabilities. All right, so how close would they be between if you actually carried out the experiment and calculated a probability and what it's supposed to be on paper if there's an even chance of it happening? So that's what we're going to look at with a bar graph on page 293. Turn in your books to page 293. So if you're looking at the bar chart on page 293, you see that it's in yellow. Okay, these are the results of an actual experiment. So someone did roll the number cube 300 times and recorded their results. Okay, so here's what it asks us. Find the experimental probability and the theoretical probability of rolling an odd number. Well, on the experimental side, I can actually look at how many times an odd number was rolled. Right? Okay, how many times was a 1 rolled?
48 times.
48. How many times was a 3 rolled?
50.
What about a 5?
49.
Okay, so 48 plus 50 plus 49. 147. Over, sorry, I'm going back to it. Over 300. Okay, 147 over 300. So now remember what we said. If we can make our denominator 100, if there's something we could do to the denominator to make it 100, I can do the same thing to my numerator. Is there a way to get from 300 to 100?
Yes, it's
How?
You do the mental math.
Well, how do you get from 300 to 100? Divide by 3. So if you divide the bottom by 3, you can divide the top by 3, and whatever number is in your numerator, that is your percentage. 49%. Okay? Now, guys, if that confuses you, you can just divide 147 divided by 300, change it to a percentage, and you get 49. Okay? You can still do that. All right? Now, theoretical probability. So wipe all of the results away. Absolutely nothing has happened. How many sides are there to a number cube?
4.
6. It's right there. It says 6 sides to a number cube. How many of those sides are odd? 3. You still have a 1, a 3, and a 5. So your chances of rolling an odd number theoretically are about 50%. There's 3 odd numbers and 3 even numbers. You have a 50-50 chance at rolling an odd number. You see that? So what is true in this scenario about the experimental probability actually rolling it and on paper what it should be? What's true about it? Are they pretty close?
Yeah.
They're very close. So here's what we know to be true. Look at the sentence at the top. As the number of trials increases, the experimental probability will get closer to the theoretical probability. All right? And that is true. Okay? And if you understand that, that's everything you need to know for part 1 of section 7.2.